Okay, so we are learning 2.1, which is talking about transformers, the shifty Y's, all right? Kind of snazzy name there. So transformers means we're going back to transformations, something that you might have learned in 8th grade / integrated 1. So this is what we're going to be doing today. We're going to find patterns in equations and graphs of quadratic functions. What happens to the graph when the equation is changed by adding, subtracting, or multiplying by a constant? Okay, so based on that, you'll see how we're adding here, see how we're multiplying here. So all of these things are going to tell you, and I'm going to teach you how I think of it so that way it makes a little bit more sense. Okay, so let's see, how do you calculate the area of a square with a side length of 2? Right? So some of you said, oh, Ms. Johnson, it's just 2 squared. Exactly. Okay, so Optima Prime is designing a robot quilt for her new grandson. She plans for the robot to have a square face. The amount of fabric she needs for the face will depend on the area of the face. So Optima decides to model the area of the robot's face mathematically. She knows that the area A, right, of a square with side length x units, which can be in inches or centimeters, is modeled by the function a of x is equal to x squared. What is the domain of the function? Okay, so let's talk about this word domain. Wait a second. Hold on a second. Hold on a second. Okay, so when we talk about the word domain, right, this word here, what's the domain of the context, right? So I want to explain what domain is. And I think we've talked a little bit about it, and you've learned a little bit about it back in other classes. But I want to make sure that you all are comfortable with this idea of domain. Let's highlight. Okay, so when I talk about the domain of a function, it's all the possible x values. And this is like, I'm going to say this over and over again. This is going to be like one of those things that you'll see over and over again. In integrated 1, you probably saw it. In integrated 2, you'll see it again. In integrated 3, you'll see it again. And in classes beyond this, you'll see it. So domain, it's all the possible x values that you can use. Okay, so in this case, right, what is the domain of function a of x? Well, what kind of numbers am I going to expect for her, for this function, right? What kind of numbers am I going to expect to plug in? And so can you guys do that for me? Can you give me some numbers in the chat? What kind of numbers, I know, right? What kind of numbers yeah, so what kind of numbers am I going to put in as the side length of this square? Yeah, we could put 2. Someone said 2. Someone said 27. Sure. Okay. Hold on. So can you give me numbers that Optima Prime is not going to use as a side length? What kind of side lengths is she not going to use? Okay, someone put 111. Okay, maybe because that's so big. So you guys are putting odd numbers. Why odd number? Why can't the length be 5? I don't know why. It could be an odd number, right? So if I built a square, if I was trying to build a square, right? Could it be an odd number? The answer is yes, right? Numbers, what other kind of numbers? So someone put like, I don't even know, I can't even count the number of zeros this person put in the chat. Someone put like, I don't know, 10 million. Yeah, 10 million, because I don't think she can like fit that in her house, that big of a square. If it was 10 million inches, you know, if she's going to sew, that would be a huge blanket. right? And yes, these robots are very gigantic, but still, yet still, right? Yes, that's actually what I was looking for. So someone said, Miss Johnson, like -10? Exactly. Why can't -10 be part of this domain? Why can't -10 be part of this domain? Yeah, like that doesn't make sense, Miss Johnson. Yeah, imagine me going to like the fabric store, like I don't know, whatever fabric store you want, and said, "Hi, and I've bought fabric before, and they're like, okay, well, how many yards do you want? I guess they measure in yards. I'd like -10 yards of fabric, please. And then what kind of face is the lady going to give me? Like, what? You want -10 yards? Right? Yeah, exactly. Someone else put 0, right? Someone else put 0. Miss Johnson, like 0 wouldn't be either. Yeah, why not? Because can I go to that same lady and be like, okay, I figured it out. I don't want -10 yards. I want 0 yards of fabric. And she's like, okay, lady, it's too much. So it's got to be a number that's just bigger than 1. Yeah, because it's negative. So for this one here, I'm writing, I want it to be any number bigger than 1. So I'm going to write x is greater than 1. Okay, x is greater than 1. Now, there's other fancier ways to write it, and I'm going to show you, not because you need to know how to do it. Okay, perfect. Thank you for telling me that you need to know how to do it. But in integrated 3, somehow between now and in integrated 3, I need you to be more familiar with it. So for me, I'm going to show it to you. You don't have to do it. If you want to get comfortable with it now to make your life easier for when you get to integrated 3, absolutely. So another way for you to do it is, and actually it could be littler than 1, huh? So I guess I should say x is greater than 0. I'm going to change that to be x is greater than 0 because it could be a really tiny square too, right? So I'm changing that to 0. So the way I would write this, and this is called set notation, is I'd write 0 to infinity. Okay, 0 to infinity. So these two things are actually equivalent. Okay. So these two things are actually equivalent. And the only reason why I want you to become familiar with this is because when you get to integrated 3 and your teacher shows you something like this, you'll be like, oh yeah, I kind of remember when Miss Johnson kind of started talking about that, because I don't want you to be caught unaware. Okay, so this is perfectly fine for us in our class, but I'm going to be putting this out there just so you can get familiar with it. Does that make sense? Very good. Okay, so number 2 says, match each statement about the area to the function that models it. Okay, so here, when we are doing this one, we're actually looking for which matches with which. Okay, so let me see. The length of each side is increased by 5 units. Now, wait. The length of each side is increased by. Do you remember being in, like, I don't know, 4th and 5th grade? I'm legit. This is how I used to do word problems. I used to think like, oh, this word means to add. So I'm just going to add the 2 numbers. Do you guys remember doing that? Right. So here, I want you to see, yeah, which one of these, or actually, what does increased by mean? In math, what does increased mean by in math? What is increased by? Yeah, perfect. Put that in the chat, everyone. Like, put your answer in the chat. Very good. So when you actually answer, you're telling me, Ms. Johnson, I know what I'm talking about here. Don't spend time on this. Perfect. So exactly. Increased by means we're going to add. So for these ones, I'm going to look either at 2 or 4 to figure out which one it is. Now it says the length of each side is increased. Does that mean A equals quantity of x plus 5 quantity squared, or x squared plus 5? Yeah, it is 2, right? It is 2 because the length, right, is the x. So if the length is increased by 5, that means x plus 5 makes sense. Very good. Very good. Very good. Thank you for telling me you get it. I appreciate that so much. Okay, next one. The length of each side is multiplied by 5. Well, multiplied just means multiplied. But if you look, I have 2 multiplied. I have this multiplied, and then I have this multiplied. Okay, wait. Physically, what's the difference between those two? Physically, what's the difference between this guy here? Oops, sorry, this guy here and this guy here. What's the difference? Yeah, both of them are squared. Ooh, but one has parentheses. Very good. Both of them are squared, but only one of them has parentheses, right? So this one says the length is multiplied by 5. The length is multiplied by 5. So which do you think that is? 1 or 3? 5x squared or the quantity of 5x quantity squared? Yeah, no, actually this one is not that. This one is it's this one, right? Ms. Johnson, why? Well, give me a second and then maybe you'll see why when we read these other ones, okay? This one says the area of a square is increased by 5 units. The area of the square is increased by 5 units. Versus this one, this is the length of each side is increased versus the area is increased. Do you see the difference? See the difference here? Yeah. So this one is going to be 4. Very good. And this one has to be 1. Now, for those of you who chose 1 for part B, do you see the difference between the length of each side is multiplied by 3 versus the area is multiplied by 3? Yeah, so the area is x squared, right? And if we multiply by 5, that would be 5 times the area. Here, we just multiplied the length. Do you guys see the difference? This is a subtle difference that I need you to understand because this is going to help you understand when we move over here to the rest of the section. Okay. So Optima started thinking about the graph y equals x squared in the domain of all real numbers. Make a table that contains both negative and positive values and graph the function. Okay, so now here, just listen. Ms. Johnson, I thought you said the domain was going to be numbers. Wait, sorry. The domain, where did I put that? Up here. The domain was going to be x numbers greater than 0. Why are they saying all numbers, positive and negative? Well, so Optima is thinking about the graph of y equals x squared, which is different than the function a of x equals x squared, which represents the area of her square, like little blanket part. Does that make sense? Yes. X squared is the area. Very good. So you want me to make some table here? Yeah, let's make a table. Okay, so this is going to be my x. This is going to be my y. They told me to use positive and negative numbers. So, okay, so let me do like -2, -1. Oops, that's not negative, sorry. -1, 0, 1, and 2. I'll just do those 5. Okay, so then I'm going to square them. Okay, I'm just going to remind you, when you square a number, right? So -1 quantity squared is 1 because -1 times -1 is 1. Okay, so -1 quantity squared, it's going to catch up. Still, -1 quantity squared is going to be +1. Does that make sense? Oh, there it goes. So -1 with the parentheses around it, the whole thing is being squared, so it's a +1. Same thing with -2, it's 4. Okay, and like you guys said, 0 times 0 is 0. These ones are easy, 1 and 2. Can you guys all see how this is going to play out? So it's going to go -2, 4, -1, 1. Do you guys all see this little shape here? This little shape guy is called a quadratic. His name is actually a parabola. Do you see the shape there? All right, this is that shape that we like, okay, because this is called a parabola. What features do you notice? You guys tell me, what features do you notice about this graph here? Yeah, it's a U. I'll write that down. It's U-shaped. I'm going to put in parentheses, it's called a parabola. Okay. right? It goes up. Very good. So I'm going to write opens up. Someone else said it's a quadratic. Very good. These are all important noticing. So I have to make sure if this is making sense to you, good job. If this feels funny to you, good job. It's supposed to feel funny because this is technically the first time that we're actually talking about it, right? So yeah, put all those answers that you said in there. Perfect. So yeah, someone said, hey, Ms. Johnson, does it mean it's positive because it's opening up? When we say this word positive, because there's a lot of stuff going on, it depends on what they're talking about. But when you say, when I read what you just wrote, there's another one that would face down like this, right? And so that we're also going to look at too in a little bit. Good question. Very, very good question. Okay, next one. It says Optima Prime was wondering about how changes to the equation, how changes to the equation of the function, like adding 5, multiplying by 5, affect the graph. She decided to make predictions about the effects and check them out. Yes, we can plug these all into Desmos and it'll say it. Okay, so right here, what I really want to think is, what do you think is going to happen to the graph? And then I want to look at the graph. Okay. So I want you to do that really quickly. So can you make your own predictions? Did you make your own predictions? Let me see. Let me anonymize you guys. Let me look at your predictions. So someone said, oops. Someone said, it's still a parabola. Good job. I like this. But it's skinnier. Ooh. Someone said, it's still a parabola. They have the same points, but it's shifted to the left. Oh, that's interesting. Huh. This one said, it's still a parabola. It's even skinnier than the first one. Oh, that's funnier. Huh? So they got skinnier. And this one says, it looks like the original, but it got shifted up. Very good. So it sounds like this person used the graphing calculator to help them do that. Really strong work. So yes, however you predict, that's going to be your own predictions. So then what happens is now she's going to use technology and actually do that. So I'm going to use technology too. And I'm going to graph. So she starts with x squared plus 5 and graphs it along with y equals x squared. So let me go to Desmos. And then let's graph this thing, because that's why this tool is so, this is why I like it so much. So x squared, x to the 2. If you don't know where to the is, it's shift 6 on your keyboard, or it's this guy right here, or it's this guy that's actually squared, right? So that's x squared. And then they wanted me to graph x squared plus 5. So x squared plus 5. Boom. Oh, that's why that person said it got shifted up 5. Oh, so the way I want your brain to be working is this. Huh, that number is in charge of moving it up 5. That number is in charge of it moving up 5. Does that make sense? Does that make sense? So what would happen if I change that 5 to a -2? What if I graphed x squared minus 2? What do you think would happen? X squared minus 2. Yeah? You think so? Yes, it would change. Good. It would be very good. Very, very good. Very good. So if so, this is what I was asking you guys about. If I went like this and I change it, did I say -2? What did I say? Minus, I think I said -2. Yeah, look. Oh, that's what you guys said. You guys said it would go down. It would shift down. That word shift is really powerful, by the way. Shift means like when I shift things, the shape stays the same. I just moved it down. So these are called translations. Say the word with me, translation. So when I have a translation, right, a translation doesn't change the shape of anything, right? It didn't change the shape. I just shifted it. I just moved it. I moved its location. Very good. Okay, so I'm going to move on to this next one. It says, knowing things make a lot more sense with representations. Optimus tries a couple more examples. X squared plus 2, x squared minus 3. Looking at the graph, what conclusions could you draw? You guys just did this. Carefully record them. And then what about for k? So what is that k in charge of? In the chat, can you tell me what this k is in charge of? What is this k in charge of? What is this k in charge of? What did you say the 5 was in charge of? What did you say the -2? Good. In which direction though? Be specific. The more specific you are, the better. And then can you guys be comfortable chatting to the whole class? Yeah, this k value. What did the 5 do? What did the -2 do? Yes, very good. So someone said, Miss Johnson, the K is in charge of, and I'm going to snip it and put it up here. That K is in charge of shifting up or shifting down. Good. Very good. Shifting up or shifting down. Let's see if I can scoot this over a tad. Oops, I copied the wrong one. How did that happen? Oh, okay. So this K actually is only in charge of shifting up or down. So I'm going to just cross out that left or right in our thing. So now you guys know. So not left, not right. Someone else is in charge of that movement. Very good. So can I ask a question? When does it shift up? When does it shift up? Yeah, someone said when it adds, Miss Johnson. That's when I shifted up. Oh, that makes sense, right? Oh, okay. So when does it shift down? When does it shift down? Okay, can you write that down as a sentence? K is in charge of shifting up or down. Up when it's this or down when it's that. Okay, I need that to be in your own words because I can tell you, but I will tell you right now, it's so much more powerful when you get those words down on your own paper. So take a second. Good. K is in charge of shifting up or down. When does it shift up? When does it shift down? When does it shift up? When does it shift down? Yes, it shifts up when you add. Very good. So I'm going to copy and paste this person's stuff because they said K is in charge of shifting up or down. Let's put that here. K is in charge of shifting up and down. It shifts up when you're adding, right? Very good. Strong work. Very good. Okay. Let's move on to the next one. Okay. Let's see. Is this where I wanted to be here? Hold on a second. Home 6. Very good. Okay. So I wanted to get to, let's see. Home 6. Oops. Did I miss it? Okay. Yeah. So looking at examples, those perfect. And then here. So here, okay. So it says, after her amazing success with addition in the last problem, Optima decide to look at what happens with addition and subtraction inside the parentheses, adding to the x before it gets squared. Using your technology, decide whether that happens. So right now, what I'd like you to do is pause. I'd like you to go over here to Desmos and play with a couple of them to give me the similar statement to what one of your classmates gave me. So here, this guy's name is H. So K is in charge of shifting up and down. H, I need a sentence kind of like this. H is in charge of what? Okay, I'm going to pause our recording. Okay, so hopefully you tried a couple. Can someone help me out? What did you try? What numbers did you try? And if you haven't answered, your goal is to get 2 things of participation in, just 2. So what numbers did you guys try? Y equals what? For you, it's 4. What did you put? So did you write like this, x plus 4? Like this? Oh, look what happened when you did the 4. Interesting. So what is that h so far in charge of? What can I try? What else can I try, guys? Okay, another number like 8. Very good. I can try number 8. So let me just copy this. If it's 8, what do you expect to happen? And when I change this to the number 8, what do you expect to happen? When I change this number to 8, yeah, it'll shift even more to the left. Oh, that's what you guys said. Very good. Very good. Very, very good. That's exactly what I was hoping would happen. So far it makes sense. Someone else said, hey, Ms. Johnson, can you try a -9? So you want me to try a -9. Okay, so right here, put -9. What do you guys think is going to happen when I put -9? What do you think is going to happen when I put -9? Where do you think it's going to go? Oh, you think it's going to go that way? Oh, you think it's going to go that way? Oh, interesting. Let's see. So the cool thing is you guys get to play around with this technology to figure out if you're right. You don't have to sit there and plug in a bunch of numbers and graph it by hand. You could just put numbers in and try. Oh, interesting. That's what you guys said. You said it would go to the right. Oh, that's so cool. So can you give me a sentence, kind of like how we wrote right here for H? Can you give me a sentence about H? So K, his responsibility is moving people up and down, kind of like an elevator, right? Can you give me a sentence about H that would help me understand this better, or your classmates? And if you can public chat, very good. Someone said, Ms. Johnson, H moves. H is in charge of moving people side to side. I like it. I like it. Moves it side to side. Shifts it side to side. That's perfect. Both of those I like. So someone said this, right? Someone said, very good. Someone said it's responsible for moving it left and right. Okay, then my question is, okay, when does he move to the left? When does he move to the right? So someone said H is responsible for shifting left or right. When? Oh, this is weird, right? Because the other one was the other way. So the way I say it is it moves it left when H is, oops, that's too close. It looked like his, sorry. So it moves it left when H is positive. And it moves it right when H is negative, right? Which is backwards, right? That's backwards, because if I think about the x-axis on the right-hand side, that's where the positive numbers are. But look at it, that's where it moved it to. It moved it to the right. You guys all see that? That's weird, right? So I like to say that X lives in backwards land. right? Left means right and right means left. X lives in backwards line. Did you guys ever play that when you were younger? Like, no, today's opposite day. Right is left and left is right. Yes is no and no is yes. And, -9 moves right 9. Got it? All right, let's just finish this little guy off. It says Optima thought that the problem 7 was very tricky and hoped that multiplication was going to be more straightforward. She decides to start simple and multiply by -1. We already saw what happens when we multiply by -1. You guys all saw that, right? So let me turn these guys off. What did you guys say? What happens when I multiply by negative? This negative. So negative x squared. What is negative x squared gonna look like? What is negative x squared going to look like? It's okay to guess. What do you think is going to happen when I hit negative x squared right here? What do you think is going to happen? Yeah, it opens down. Very good. Exactly. Thank you for sharing that. Yes, it faces down. It opens up down. It doesn't look like a U anymore. It kind of almost looks like a little, N. So just to show you and to prove, that's what you guys said. So that negative is in charge of opens up or opens down. Wait, does that make sense to you? Okay, very good. So Optima is encouraged because she was able to figure out the last problem. She decides her investigation for the day by determining the effect of a multiplier, A. In this equation, it's ax squared. You guys talked about this before, and someone talked about it being like skinny. Do you guys remember that? Where was that? Right here, somewhere here. Yeah, someone talked about it as being skinny and skinnier, right? Do you guys all remember that? So I just want to show you what happens when I change this negative to a 5 versus our original guy, x squared. Do you see how we say he's skinnier? Anybody want to take a venture on how to make him fatter? Now, some of you are like, oh my gosh, Ms. Johnson, don't worry, it's okay. If you don't understand everything, you're in the right place. You're not supposed to. And I'll come up with a conclusion that it'll all make sense. Can anybody guess? Oh, we are on the 7th slide. No, we moved forward. We moved all the way, like we're problem 9. So I just kept moving forward. Right? So here, really quick. No, that's okay, because I have it for you here. You have it here. Don't worry, you didn't miss anything because you've been paying attention. Okay, how would I make this guy fatter? How would I make him fatter? If 5 meant skinny, how would I make him fatter? Now, don't worry, he's a parabola. Increase the number to like what, 100? Like 10? Let's see if that works. You guys ready? Look at 10. Ooh, is that what you wanted? Oh no. Okay, someone said -5. Let me try that. -5. Oh no. Is that what you wanted? I want him to be fat, like a big bowl, like. So 100 didn't work. See, 100 made him skinnier, even skinnier. 10 didn't work. It made him skinnier. Yeah, 1 makes him fatter than 5. Do you see how 1 made him fatter than the 5x squared? So -20 is actually going to make him upside down skinny. right? Negative 20 made them upside down skinny. Good guesses. Okay, I'm gonna leave that one right there so that you guys can figure this one out. So, oh wait, it said use both positive and negative numbers. You guys did that. Oh wait, we didn't try fractions. Shoot, give me a fraction quick. Or 1/2. Oh, that made him fatter. Wait, let's make him a little bit bigger so you guys, oh. So what made the fraction not skinny? What made the fraction skinny? Okay. Okay. So here goes. I need us to talk about this. I promised you guys. Now, I'll just be honest with you. If you don't have all this filled out, but you have this and this makes sense to you in your head, you can go back and fill those out. Am I right? So what was K in charge of? Let's finish this off. What's K in charge of? So where's K? Let's see. Where did K go? K is this way probably. Yeah. So this is what K. So K is looking at slides 7 and 8. What was K in charge of? What did you guys say K was in charge of? Oh, that's right. Someone said up and down movement. So K is in charge of up or down shifting. Up when K is positive and down when K is negative. Okay, so for those of you who are like, Ms. Shanta, I forgot to fill out those slides. No worries, no worries. So now you know how to fill out slides 7, slide 8, right? Okay, so slide 9 was H. Oh, do you guys remember what H was in charge of? Anybody remember what H is in charge of? What's H in charge of? Ooh, somewhere else already put it. Very good. Sorry, I need to make this bigger. Move this over a little. Very good. Okay. So shift this up a little. Okay, there. So then H is in charge. You guys said in charge of moving, of shifting. I'll use the word shifting left or right. Now, remember, H lives in backwards land, right? Remember we talked about living in backwards land? It moves it left when it's which way? Positive or negative? When does it move it left? Yeah, very good. When H is positive or right. When H is negative. Make sense? Okay. So remember, this is all supposed to come together. Oh, wait. Oh, here, this one. We have x minus h and x minus h squared. Okay, so let's just put this down here so that we all know h is in charge of shifting left or right. Left when h is positive and right when it's negative, like x plus h versus x minus h, right? What was this negative in charge of? What did this negative do to our function? I forgot. What is that negative do to our function? Yeah, it reflected it downward. Very good. All right, so I'm gonna pause this.